Hello, everybody. Welcome to IPDLN 2020. This is the data linkage session, and my name is Kim McGrail, and I'll be your session chair. If this is a sponsor, or sorry, in this session, there will be 4 speakers of 10 minutes each, followed by 20 minutes of questions and discussion. If you have questions for the speakers, please use the Q&A function to ask questions. You can enter your questions at any time during the presentations. And the first speaker today is going to be Emily Berkowitz from the Actionable Intelligence for Social Policy at the University of Pennsylvania.
Great, thanks so much. Happy to be here. So my name is Emily. I am a project manager at Aisp. I'm stepping in today for our Director of Training and Technical Assistance, Amy Hahn-Nelson. And I'm going to be talking a little bit about our developmental approach to shared data infrastructure. So at AISP, we are an initiative that supports cross-sector data sharing for insights in government policy and programs across the United States. Our purview is about 22 operational state and local integrated data systems. We have about 14 more sites currently building toward active data flow. They're well on their way, and we're excited to continue to support them. I'm going to talk to you just briefly about our approach to data linkage, right? We know that data linkage means many different things to many different people. So what we are focusing on in particular are efforts that integrate data across at least 3 different domains or agencies. That's what you're seeing in that lovely little wheel there, the different government services that might be sharing data in order to get a better insights about the folks that they serve. We're also focusing on efforts that serve as a kind of public utility, right? We're answering questions that are pressing for government stakeholders. We're not doing research just for research's sake. We want to make sure that the people who are served by these programs are having questions that are asked and answered relevant to them. And we're also talking about efforts that are a long-term proposition with a clear organizational home and defined governance structure. So that means we're not talking about data linkage that is done for a one-off or ad hoc project. So that's broadly what we mean when we talk about integrated data systems or IDS. And building infrastructure for a fully functioning IDS is best conceptualized from our view as a pyramid. It has to be built from the ground up, right, with really strong governance at the bottom, those really strong relationships between data sharing agencies and other stakeholders. And then each layer is providing support to those that come on top. Now, these layers are interdependent and they help sustain each other. So we can't consider something fully functioning until all the pieces are in place, but building that requires some time, right? And that's where our developmental approach really kind of comes in. We have the AISP learning community where we help sites who apply and are accepted into the program over the course of 18 months to develop these core components of an IDS to get those in place so that they can have active data flow, right? But the challenge is that when folks join the learning community, we're all at very different stages, right? Different efforts have achieved different pieces of that larger puzzle. Some folks may have had their data sharing agreements already created. Some folks have really thought through the nuts and bolts of what does it mean to actually integrate and link data. Some folks aren't quite there yet. So having a AISP having a background both in community organizing and social work as well as development really drives our thinking in terms of the approach that we take, so we're going to get a little into the child development piece here, which is the zone of proximal development. Amy, who I say I'm stepping in for, was a second grade teacher for many years. And so this ZPD is really the same thing that you would think about when you think about learning to read, right? You can read a book that's at your current understanding. You can do so unassisted, but then you can also challenge yourself a little bit more, taking home a book that's going to require maybe some support, maybe some feedback. And then there are also activities that are going to be really far out of your reach. And so because that there are these layered ways of learning, there's a really deep need for focused teaching, right? The arrow here is the goal of our work at AISP and through our learning community. We want to get every site into this sweet spot of learning without boredom, but without anxiety. And so everyone should be moving forward together, but starting out with walking and not running, right? We really encourage sites to take it slow, to celebrate their small wins before trying out advanced projects. That means doing basic descriptive work before you are, oh, I'm so sorry, I realized I'm not on the right screen. Here is our arrow that I'm referencing. So the idea is that in order for everyone to be in that sweet spot, we need to be drawing on AISP staff, AISP faculty, and each other. We have to really create a community of learning. And that means owning the stage that you're in. That means talking to other folks and asking lots of questions. Part of this process really is the struggle. But the thing with IDS is that, you know, we always say, if you've met one IDS, you've met one IDS. As we are working hard to hold and support our sites within that zone of proximal development, an important part of this work is also remembering that there isn't one right way to build or grow or create a data linkage system, right? Flexibility, creativity, and patience are all really central to this work. But at the same time, as this field continues to grow and change and emerge, there is more of a need to think specifically about what sites, how they organize themselves and how they look both similar and different. So we have been working to understand those connections and similarities, and we recently conducted a landscape analysis survey of efforts across the US, both within our network and outside it. This survey was built around the qualities of that pyramid that we showed earlier, but it also uses you know, our decades plus of experience at AISP to think more broadly about what are the key distinctions among efforts. You know, that pyramid is really about the quality and maturity of an effort itself, whereas the taxonomy that I'm about to show you is more focused on where are the places that big decisions are made, where are the pain points potentially, and where are we setting foundations across sites to help them learn from each other, right? Each of these tiers, they build on each other. The level of geography that a site operates at will influence the management model or who it is that's hosting an organization. And that will help influence the infrastructure and the capacity to perform the various activities of an IDS. So just to go into those a little bit more, here we have the geography, right? This is that first tier. Under local, we're thinking about city, county, and regions. Just for everyone to know, the breakdown of our survey was 52% state level sites and 48% local. So a really nice balance between those. The next piece is the management model. And this is really who is overseeing the three key activities with IDS. You have your governance, your actual integration or data flow, and then the analysis and presentation of findings. So within each of these hosts as well, there are a series of other decisions and things to consider that are affected by geography, that are affected by the relational capacity of an IDS, that we also tease out a bit in this taxonomy. Next, we have the kind of core final piece, which is your core purpose. How is the data being used? And the core purpose is something that really attaches back to the mission of an IDS. When developing this at such a local level, you know, state or local, but still not at the federal for the US, we're thinking specifically about a purpose of using data for social good. And so how data are then made actionable, it's really important to think about what is possible technically, what's legally feasible, and also what's relationally feasible. So altogether, these three key core components of the taxonomy are designed to help sites come together and to further foster the developmental approach of a joint community learning process that we use at AISP. So I will invite you all to think about what these organizing principles could mean for data linkage in your context. And I'm looking forward to hearing from the rest of our panelists and to the Q&A. And I encourage you to check out some recent publications from AISP, our introduction to data integration, as well as our toolkit for centering racial equity throughout data integration. Thanks so much.
Fantastic. Thank you so much, Emily. That gets us off to a great start. And just a reminder to please go ahead and start asking your questions in the chat if you have them. And meanwhile, I'll move us along and introduce Richard Hier and Shirley Wong, who will be presenting. Richard's from the Swansea University in Wales, and Shirley is from the British Columbia Ministry of Health.
Thank you, Kim. Richard, can you advance the next slide? So I'm very happy here to present today our presentation. And as Kim mentioned earlier, we're going to co-present. Can you go next slide? But before I start, I just wanted to give you a brief context about BC. In terms of geography, we're about 4 times the size of Great Britain, but only 5.1 million of the people live in half that space. Our claim to fame is our mild climate, which I immensely enjoy. We have the world's largest hockey stick, and Pamela Anderson is our Canada Centennial baby. Just briefly about the services, we're largely publicly funded, and we have a mix of partners that provide the service. On the private side, that also includes our physician services, just to give you a brief context. On the next slide, I'm just going to briefly describe some unique characteristics about the Health Data Platform. This platform supports research and analysis. It's not just an environment that we've built for research. We recognize that common infrastructure could be leveraged to support both those needs. The other thing that we're looking at is a federated environment. We're trying to move away from a centralized data holding. We're moving towards a federated data access environment. The other thing is we have worked, the Ministry of Health has led the work to date, and we have been working with several partners. And to date, I will note the relationship that we've had with Swansea University. On the next slide, it shows sort of what we've built. So at a very high level, we launched our services in July of this year. It has been built on the Azure environment. We've established an interim governance structure where we've brought our health authority partners and the ministry under a common framework, which also includes a data access framework built off the 5 safes. So we've built common processes for cross-organizational data requests, because in the past, you would have to go to each organization and fill out different sets of paperwork, different approval processes are followed, and different mechanisms for how you get the data. So what we've done is streamlined all of that with the intent to increase transparency and just basically faster access to data safely. On the next slide, I know I'm going through this quite quickly. I want to give enough time for Richard, is the 3 benefits that we hope to get from this. And one is around balancing analytical utility with privacy. As you can, what I've just said, those are at opposing spectrums. So how do we find the right balance? And the way we've addressed that largely is building the appropriate compensating controls from a security perspective so that we can hopefully relax some of our privacy requirements so that we can have that maximized analytical utility. So our July launch has largely been focused on building up that security piece with a security threat risk assessment. And then right now we're addressing the high priority, the meeting level risks that have been identified through that. The other is a general recognition that how do we get more coordinated in providing our administrative data holding for the sector in this province? Because we have a wealth of data. So how do we better leverage that to support the complexity of our system and try to understand it better? So the real thing here is around what all this other previous speakers have mentioned is how do we create trust? How do we build that, meet our fiduciary accountabilities around the public asset that we hold, but also at the same time, how do we maximize its value? And the third is around collective governance. This asset cannot be built by any organization alone, including the ministry. All of us have to work together. All of us have to come together to even the landscape. A large criticism that we've received is because it's so uneven, it's so cumbersome and difficult to navigate. So how do we work towards building those common processes, which is what we've been doing now, rationalizing our approval framework so that we can go to one stop for approval and also basically improving the whole data consumer experience. And one of the things that we've built also is create a common front counter for researcher access. So I'm just going to turn it over to Richard, who will elaborate on why we've become partners.
Thanks, Shirley. In this partnership, SERP was developed to meet the needs of the SAIL data bank. So some of you are not aware, SAIL is Wales's response to the delivery of a citizen-centric, so if I want to say it tended to, individual level data at scale, linking together health and social data from across public sector in Wales. So SERP is used across the UK by 23 different research organisations, and we do that based on a shared infrastructure model here in Swansea. Again, SERP is also used in Australia in both Curtin and Monash universities. And actually, Wales and BC are quite comparable in size, to be honest, Shirley, from a population perspective. But just to remember, BC may have Pamela Anderson, but we do have Catherine Zeta-Jones. So just like to leave you all with that. So how are we meeting the challenges that Shirley puts forward? So she's mentioned the 5 safes. So SAIL was developed and the principles around the 5 safes. So for that, for data access, we've got the safe settings, so a standardizing desktop environment for end users there. With the data security and privacy, we've got the principle of safe output there with an airlock mechanism, so information can't leave that secure research platform without an approval mechanism. Here in Swansea, SERP has been designed with ISO 27001 compliance in mind. And built into that is a role-based access model. So users are assigned to roles, that they're given access to specific projects, and those projects are time limited. So access is removed at the end of those projects. As well as that, one of the challenges is around data management, and something Shirley just mentioned is around the end consumer, so data consumers. So we're offering as part of that as a single data catalog tool set, so end users are able to see the data assets and data holdings on offer, and understand the different variables that are available. And as well as that, there's also some data provisioning tools. So the idea being that Shirley's team are able to provide those data to end users, maybe chopping up accordingly. And as well as that, there's also the data matching. So something that Shirley mentioned within the middle of all SERP products is a data linkage solution provided by Curtin University. So how is Shirley and I working together? So it's collaboration is essentially the key component of our working relationship. Within the piece of work, there's multiple organisations involved. There's the MOH team, Swansea, and CGI, along with the tech people within BC. So we're all working together at a shared view of the challenges. And we've had some very open and honest conversations, and difficult at times. So Shirley mentioned it earlier, there's been some pivots as part of the project, and they've definitely challenged us at Swansea, and the July delivery was a real pressure for us. But they challenged us, but SERP is now cloud native, and we're, I guess, stepping up to the plate on that one. So as part of this project, we're working with Shirley and the team around a delivery of project phases to meet the immediate needs. Shirley mentioned the July delivery earlier, and that was around an MVP, so just essentially the bare bones of a secure research environment. Our next release will be around the end user consumer products, so around the data asset and data cataloging products, so making more, so where the data assets are available, those end users are aware of them. The second release, or the third release, sorry, will be around data linkage, you making more use of the data linkage product, and some other AI and machine learning tool sets that are available in this space. And then the final release will be around our NLP tools that we have available, and then the dynamic warehousing to meet the needs of the various health authorities. And just to finish off then, I guess those products we're delivering in those phases to actually meet the needs then of Shirley's team, ensuring that there's appropriate governance between us in the project, and ensuring that when we provide various features to the project, it enables them to work at an appropriate pace, and essentially still very much a learning curve from us all. Thanks, Kim.
Excellent. Thank you both very much. So we'll next move on to Michael Schull from the from ICES in Ontario.
Okay, I'm just gonna bring my screen up. And I hope everyone can see that. First of all, thank you to the IPDLN for the opportunity to present here. It would have been lovely to be there in person with all of you, but of course none of us can do that. So we're doing this strange virtual presentation, but it's still great to see faces and hear some familiar voices. I'm going to talk about an effort to build a research partnership between computer scientists and health services researchers for access and analysis of population level health data sets. And on this slide, I just want to draw your attention to the bottom of the slide, which lists a whole lot of co-authors. There are a lot of individuals who are involved in this project, and I'm lucky enough to present it for them, but there are many people involved. I have no conflicts of interest to declare. So many countries are applying artificial intelligence and machine learning methods to improve health and healthcare. We've heard a number of examples of this in the sessions already at the conference. And health service researchers have carried out research with the same objective on large population level health data sets for many, many years, but generally using more traditional statistical methods rather than AI and ML. Applying AI and ML methods to large population level health data sets is likely, in my view, or in our view, likely to benefit from successful collaborations between computer scientists, machine learning researchers, and health services researchers. And so this was really the driving impetus behind the effort that I'm going to describe in a moment. I'll just add that our work started a couple of years ago, but more recently, COVID-19 has added additional urgency and resources to these efforts. So who are the partners that we brought together in undertaking this work? Well, in Ontario, there were three main partners, the first being High Performance Computing for Health, or HPC for Health, which is a public sector organization based at a hospital in Toronto that took the lead on the infrastructure build and maintenance. My institute, ICES, was the lead for data governance, data and data access models, and brought clinical subject matter expertise as well as health services research expertise. And then the Vector Institute in Ontario was the lead for machine learning expertise, a key user of the HIDAP, which I'll describe in a moment, and played a key role in defining the essential functions, the specs, and priority data sets for the HIDAP. So what is the objective of my talk? I'm going to talk to you, I'm going to describe lessons learned and actually still being learned in how to create effective partnerships and collaborations between AI and ML researchers and institutes with health service researchers and institutes. So what did we do? Well, the first thing we did was we crafted a partnership between the organizations that I just described. We built a high performance computing platform, the so-called Health AI Data Analysis Platform, or the HIDAP. We created the necessary policy and legal framework so that administrative health data and other data such as EMR could be placed into this environment for research and analysis. We enabled computer scientists and health service researchers to collaborate on the application of AI ML methods to EMR records and population level health data. And the HIDAP was officially launched in 2019. This is just a conceptual figure of what the HIDAP is. On the left here, you see ICES. This is our traditional analytic environment. This is a large data repository that has existed for about 28 years now in Ontario. To the right, you see HPC for Health, which is a separate high-performance computing environment that operates as a private cloud. And we created a secure tunnel to transfer data from our traditional environment into the high-performance computing environment, created a tenancy under our governance, so our policies and procedures would apply, and then enabled remote access for approved researchers. The data that we're talking about that are available within the HIDAP come from the ICS repository, which now represents about 100. So this 95 plus is a little bit out of date. We have about 100 structured and semi-structured linked databases, mostly at the population level for the population of Ontario, which is about 14.5 million people. This represents about 18 billion lines of data, about 750 billion data points. These are the ways that I've learned the computer scientists like to understand how much data you have. So I like to express it that way. It also sounds very impressive. We have about 20 million patient life histories, representing, of course, both living and deceased people in Ontario, and about 500,000 individual primary care electronic medical records. So this includes free text for primary care patients in Ontario, all of which are linked to the rest of the data. So what are the lessons that we learned? Well, the first one is the importance of institutional partnerships and the alignment with the priorities and strategy of those institutions. So I mentioned the three partners we had, and for each of us, it was a priority and part of our strategy. Also, the potential need for institutional risk-sharing models. There are quite a few risks that are involved in these kinds of undertakings, and in fact, the risk-sharing models between public sector organizations are often not well developed, and in our case, continue to be a work in progress. You need to be able to enable and promote scientific collaborations that bridge disciplines around joint research projects. It doesn't mean you always need to have a combination of, say, health service researchers or clinician researchers and along with computer scientists, but I think the best research happens when you do have those collaborations. We should also recognize different scientific cultures. So the computer scientists and health service researchers come from different scientific traditions or cultures. And just one concrete example, for a computer scientist, academic credit really comes from conference presentations and proceedings. So that's where they get the biggest sort of bang for their academic buck. Whereas for a health service researcher, it tends to be in the form of a publication, which tends to take more time. The turnaround is longer, and that leads potentially to some differences and potentially tensions. There are similarly differences in research timeline expectations across those groups, and differences in experience with and expectations for access to de-identified, routinely collected health data. So if you're a health service researcher who's been working with this data for a long time, you understand that there are policies and practices and forms and hoops you have to jump through. Not so clear if you haven't been working with this data in the past. Final set of lessons that we've learned is that, or continue to learn, is that there is a desire and a need to develop access models that enable greater flexibility. We haven't fully achieved that yet. We're still working on that. But this would include things like the desire on the part of computer scientists to import code from whitelisted or even open source GitHubs. And this is typically not something that we can easily do for security reasons. And so trying to work out those sorts of mechanisms is an interesting challenge. The need to broaden data access models to allow for modern high-dimensional exploratory data analysis. This is often a challenge with some of the, for example, data minimization principles, privacy principles that apply to this work. Ensuring you have ongoing support from your information and privacy regulator. And realizing at the end of the day that the hardware build is a relatively easy part compared to many other success factors. And I think, unfortunately, we tend to forget that and get focused on the hardware when in fact that tends to not be the hardest thing we have to do. So outputs to date, there have been 41 research projects so far launched in the HIDAP, and this is separate from the rest of our analytic environment where there are, of course, many more projects. There are 7 computer scientists or students who are collaborating within the HIDAP, 24 research projects using machine learning or natural language processing. 12 of those involve students. We have also expanded some of the legal authority pathways to access data for analytic purposes in the HIDAP. And I'll speak about this in a little bit more detail in a moment, but there's been expanded infrastructure with the launch of the Ontario Health Data Platform. So here are just a couple of examples of studies that have resulted from the HIDAP. This last one that you see at the bottom of the screen is just kind of interesting because this is actually not an analysis. It's a review of the literature, but one that was done jointly by computer science and health services researchers, which I thought was an interesting outcome of this work, and has been preparatory for current work in the HIDAP on cardiovascular outcomes associated with COVID. So this is what I mentioned a moment ago, the new Ontario Healthcare Platform, which was just launched this year. The Ontario government has decided to invest additional resources to build out both the HIDAP and a second high-performance computing environment, and to populate that with population-level data to support the COVID-19 response. So in conclusion, institutional partnerships are key to successful collaborations. Efforts to enhance systems and processes to enable more efficient data access and analytic tools for machine learning analysis of health data remains a work in progress. Our HIDAP has enabled multidisciplinary collaborations and novel AI/ML research on EMR administrative data, and COVID-19 has provided an impetus to accelerate these efforts. So thank you very much.
Great, thank you, Michael. So our last presenter will be Geoff Neideck from the Australian Institute of Health and Welfare.
Okay, thanks, Kim. Just sharing my screen now. Okay, well, it's been fantastic to hear those previous presentations, and I'm going to be talking about some of the lessons from the Australian perspective, and very much picking up on a number of the themes that have already been presented on. So just to give you a bit of an Australian context, like many countries and like the presentations that we've seen to date, there's been progressive movement to increase access, particularly to public sector data sources. And in Australia, that's been propelled by a range of different initiatives, including a federal inquiry into data availability of use. But we've also seen some initiatives around public data policies and importantly, some legislation change either enacted already or in progress, which is opening up access arrangements to data. All this has led to considerable increase in dialogue across public agencies and importantly across our jurisdictional boundaries. AHW, the Australian Institute of Health and Welfare, as a Commonwealth Data Integrating Authority, and with a particular relationship between state and Commonwealth agencies, it's been well placed to be able to provide advice, technical advice, and to be involved in a number of key developments, including investment in infrastructure. So work that we've done to improve the interoperability of our data linkage spines that are held by different agencies, developing platforms for access to data, and including our own development of a secure remote access cloud-based environment that we've stood up recently. Recognising the need to produce contemporary, scalable and flexible data resources, we've established a number of key data assets that are both more enduring, but also multi-use in terms of being able to provide better access to Commonwealth data, bring data together and make it available, moving away from the traditional create a data set for a project and then destroy that data set, and using a whole range of technology and other developments around governance and data models to be able to bring their data together. So we've produced a National Integrated Health Services Information Data Asset, which brings together our medical payments support data with our hospitals data held by our states. And that data asset is now being used for some really important research. Similarly, we're involved in the creation of a national disability data asset, which is really pushing the boundaries on some of our sharing and arrangements for accessing data. We're also in the processes of looking at other data assets, such as a data asset on cancer treatment, and similarly one on diabetes. And we'll see many more of these come along. So in recognition of the creation of these assets, we've coined the phrase multi-source enduring linked data assets, and recognizing that we need to be able to create assets that are scalable, both in terms of the data that they bring together, but also in their flexibility to be able to support different uses of data. Of course, in doing that, we maintain traditional approaches to data integrity, to privacy and security of the data. But of course, these approaches are testing our ability to be able to maintain those while we introduce new, innovative and improved techniques for accessing data. So I'm going to look a bit more closely at the nature of the melders that we've created at the Australian Institute of Health and Welfare, and talk some more about some of the lessons that we've learned, similar to some of the lessons that have come through with the other presenters. But I think some of the unique things that have arisen in Australia but might be valuable lessons to others. So just in terms of the nature of melders, and of course, being an Institute of Health and Welfare, we're dealing particularly in person related government administrative data. But in terms of multiple sources, we're looking at bringing data together from many different agencies across our Commonwealth national data agencies, but also from our eight state and territory data agencies and policy agencies. And of course, that means that we've got data being sourced from a whole range of different locations in different formats, subject to a whole range of different governance arrangements, and involving many different partners to be able to do this work. So for example, with our national disability data asset, we're working at the moment through a number of test cases. We have 3 states involved, with many agencies from those states, along with our Commonwealth Department of Social Services and our Department of Prime Minister and Cabinet. Starting by looking at how we might produce an enduring asset by looking at a range of different sectors. So we're looking at a test case on justice, one on early childhood development, one on education to employment, and another on mental health. The trajectory for these developments will expand to all our Australian jurisdictions, across many more sectors where we'll bring in data, and eventually we will be looking at a data resource which will have well over 100 data assets supporting it. The melders that we're looking at are, of course, not only multi-source, but our objective is to ensure that they're multi-purpose. So, we're looking at a range of different, quite disparate uses of data, which will require some very innovative design thinking in terms of how we'll support that through our data creation. So purposes around obviously policy development for government, but also government reporting and standardised performance measures, portals and digital platforms for persons with disability and others in the Australian community, and of course a whole range of different research activities that will be supported by these assets. The design approach that we've adopted at the Institute has three core elements. All our data sets are linked together with a spine, which is derived from AHW's national linkage map, which is interoperable with linkage maps from each of our states and territories, but also with our sister organisation, the Australian Bureau of Statistics. At the core of our assets, we'll bring together demographic and other important information, particularly national information, to create a core element of our data resource. And that will include some of our more frequently accessed and used data. The third key element is where particularly states have data assets which are not necessarily comparable at a national level, or where we have data sets that are not frequently accessed. We've created a concept of satellite data sets, which will be stored separately, but will be enabled through our linkage map to be linked on demand as required. We're also working with a number of our states to enable them to create elements that would go into a national data asset by bringing together data sets at the state level, undertaking their own linkage, and then linking further into the national asset. So this work to date, while it's still in its infancy, has enabled us to gain some important lessons that we'll be able to work on in terms of further developments into the future. So I'm going to look at three different areas for lessons learned. The first of those is around policy and governance. And it's been quite evident that the data authorising environments for different very disparate data sets certainly aren't always clear, particularly when we're thinking about uses of the data which are not the primary uses and not the primary causes of the data being collected. So those secondary uses, testing legislation for these new uses, identifying key decision makers, and embedding those in our governance processes. All of this is highlighting, again, issues around new and different uses of the data, gaps in government and whole of government and cross-government data policy, in terms of thinking about how data is used, but importantly from data custodians' perspectives, what are the conditions under which they can maintain some visibility of control, but enable trusted users to be able to access that data. Like many countries, we apply a 5 safes framework to these types of questions. But what we're missing at the moment is better governance models that set parameters that sit between that end of the spectrum where data is pretty much open and doesn't need much control, through to those really tight controls of the no risk or minimal risk models. So we're working with both government agencies, but also with the university sector, looking at what those models might be, which would enable better approaches to balancing control and the trust with users. Importantly, we're learning a whole range of new and different things around the quality of the data as we attempt to bring it together. Building on lessons that we've learnt from previous data linkage over a long period of time, but it goes without saying that data is only as good as the metadata and supporting documentation that is available. We're finding new challenges as we try to harmonise data from these very, very different sources of data that we're bringing together. One of the risks that, of course, that we manage is that where there are gaps in the data or where there are poor information about the data, we end up sort of outsourcing the problems in managing those issues to the researchers. And so we need much better and more efficient ways to be able to gather that information together, adapt them to the new uses of data that we're seeking to support, and work with our partner agencies to put in place better programs of data quality improvement, and capturing the information that's needed to support uses of these data assets that we bring together. We're also highlighting very significant gaps across government in data capability, and with testing some of the boundaries with new access arrangements to data and more innovative uses. We're finding that while there's been some good development around data linkage infrastructure and data linkage arrangements, we still don't have the necessary skills development that is required to support these very, very complex and new arrangements. So on the skills side, we've seen some good initiatives in Australia. One recent one is where we're working with at the Commonwealth level with the Public Service Commission to establish data professions and ensure that we can build and uplift the data skills, data literacy, and so on for data administrators and policy developers. Importantly, there are some really good signs, I think, in terms of being able to work across agencies in terms of partnerships, which will enable us to gain some good improvements in the future. And similarly, looking at some of the technology solutions, which are very much struggling with the complexity in the data and the initiatives that we're trying to develop. But as others in this conference have demonstrated, some of the machine learning and AI approaches are very much providing some good opportunities. All right, just quickly, just wrapping up, some of the key challenges that we've got ahead just very, very quickly. In terms of creating multiple melders where we're reusing the same source data sets across many of these melders, the issue of copies of sensitive data is one that we need to be continuing to look at address. As I've mentioned, managing trust versus control issues, looking at better ways of using government expenditure by sharing infrastructure in terms of hosting and access to data, and those issues of harnessing technology to reduce clerical effort and improve efficiencies in processes and in analysis. So thank you very much.
Fantastic. Thank you. Thank you to all of our speakers. You can see the uniting theme under this around data linkage platforms, but quite a different approach with some different motivations and different audiences as well. So, and I think some of the things that we can see here that are quite common across this is a really a focus on governance, a focus on users and particularly new types of users, but also this imperative to share and to learn from what others are doing. So some questions have been coming in, so we're going to turn to those now. And the first of these is directed at Michael, but I will invite others to weigh in if you wish as well. And this has to do with the question comes from Australia and recognizing that we're seeing increasing demand for epidemiologists and health services researchers to be data scientists. And so there's a lot of us, and I'm included in this one, who were trained before the existence of data science and these new methodologies. So how do we address this? Are we addressing this? Is there a good way to do that?
Thanks for that question. And please, Kim and other panelists weigh in, because I don't particularly think I have special expertise in answering it. The first thing to say is I think a data scientist is, whatever you want it to be these days. I think a lot of people describe themselves as data scientists, and I don't really know what that term means anymore. So I think all of us are probably data scientists. You know, if you're a health services researcher, if you're a statistician, if you're an AI ML researcher, you're all working with data and you're scientists. So I think the first thing is the term, it's a bit like big data. I mean, it's just a term that really has no actual meaning anymore. Maybe what you're getting at though is that increasingly, you know, more traditional health services researchers are being asked or expected to work with methods in machine learning or natural language processing or deep, you know, neural nets, that kind of thing that, you know, we weren't trained to do. And that I think actually is a bit risky. I mean, I think it's like, you know, to me, these are tools. They're not magic. They are tools like any other statistical methods. But you need to know what you're doing. And I think it's easy to you know, to just embark down a path where you're kind of blindly applying methods you don't fully understand. The converse also applies. You could be absolutely expert in machine learning, but not really understand the data you're working with and how those data sets are generated. And I think equally there are major risks there. So, I mean, I think, you know, I'm a physician as well as a researcher. So, you know, I have a particular specialty. If someone came up to me and just said, well, I want you to be a cardiologist tomorrow as well, I'd say, no, I can't do that. So I think, you know, resisting that tendency to be forced into a jack of all trades box is probably a good way to go. But I think it speaks to the point that I was trying to make, which is that we need to figure out how we can effectively collaborate. And you know, in our case, it's still a work in progress. And by that, I mean to collaborate with the computer science world, which is quite a different world from the world that certainly the world that I traditionally have come from.
Does anybody else want to weigh in on this one?
Just, I'll jump in for a second, Kim. Just to echo some of the comments by Michael there. It's a repeating theme that we hear across the UK, and it's some of the challenges that we have with users of the technology. That they're not all experts, so coming at different perspectives. So lots of that resonated with me personally.
So let me go on to this next question, which is actually quite related, and it's an observation that there's often different terminologies between more traditional health services research, I'm just going to pick on that, and the data science machine learning world. There's different terminologies for what are effectively the same thing. Of course, this is true within HSR, probably within machine learning as well. So should we be creating a dictionary for this? Should we be trying to move it up a level and coming to some more common understanding? Should we actually have a degree that combines data science and health services research? Like what is the way of the future? If there's any quick response to that before we move on, I'd love to hear it.
Well, Kim, I mean, again, I think the answer is yes. I mean, I think yes, we want to have some sort of common language. Yes, I think having common definitions is important. I think the question is, how do you get there? And probably, I think it is, you know, the idea of combined degrees, that is starting to happen. We're seeing that increasingly, you know, in my university, University of Toronto, where there are combinations of sort of AI with health services research degrees, or clinician scientists who are being trained also in AI ML methods, or centers focused on the application of AI and ML to health data. So it probably will happen more organically over time, but I think for sure that there is a need for efforts to actually accelerate that you know, that sort of combining or joining of forces, I suppose.
Okay, so let's, this is now quite a different question, which has to do with interoperability standards. So, the question is that there's all sorts of existing standards like FHIR and metadata standards such as Meteor, I don't know that one, and other things like LOINC and SNOMED. So how do you currently select suitable standards to follow when building health data platforms? I think I might aim that at Richard and or Shirley to start with.
I was going to say we don't. Only because I'm not sure that we can do the mapping and translations in the highest fidelity that we want to do. It's a long journey. I don't think there's an easy answer to the question that you're talking about. It's how do we get to a place where it's common enough so that you have the integrity that you need for the purpose that you want it for. And sometimes that's just subject to human interpretation for the next little while until we do some awesome things with machine learning or something to do all the synonyms and capture all the nuances that we're after. So I think my initial answer still stands. We don't do really anything for now, and we just acknowledge that a whole bunch of them exist. I'm sure that's an unsatisfactory answer. I'm not sure Richard has anything to add to that.
I was only thinking I wish Simon was here because I'm sure he'd have some words of wisdom on the topic. No.
It's Geoff Neideck here. I'll jump in on this one. And just on that issue of Meteor, that's the Australian health metadata classification system. Look, it's a real challenge. Matching data classifications between, government data and, the clinical environment and, other health settings has been just a real challenge when you're bringing data together for research. We haven't seen, really, good and efficient solutions to that. We've seen lots of workarounds, lots of approaches to sort of cobble together concordances and so on. Look, I agree with Shirley. It's a real challenge that we haven't been able to crack yet.
So a different flavor on that question is coming as well, which is one of the issues that came up yesterday in some of the COVID-19 discussions related to the use of common data models like OMOP and Odyssey. So do the speakers have any experience with their views on applying these models in repositories or platforms? Anyone who wants to speak to that?
Well, so I mean, I have very limited experience, but what I will say is that where I think, in my experience, I've seen this applied more commonly has been across different jurisdictions, essentially. And you can think of jurisdictions in different ways. And in the case that I'm involved in, and Kim as well, is in Health Data Research Network Canada, where we're looking to develop analytic approaches to distributed data across different jurisdictions, but it's essentially similar data. It's hospitalization data, or it's physician claims data, or it's whatever, prescription data, or it could be education data, social service data, and you're trying to make that comparable. And there are different ways of doing that, but certainly a common data model is one way to do it. Within a data repository, or if you're working consistently with data sets over time, I think you don't necessarily need to create a common data model per se, because you actually have the ability to standardize definitions and create definitions, often by virtue of linking across multiple data sets to define conditions or diagnoses and so on. So a common data model is not as necessary, but I suppose it is still possible. And I guess one question is, what about in a federated data model, which could be within a jurisdiction? Might there be advantages to a common data model approach? I don't know the answer to that question.
I think the only thing I'd add to that is, why do you want a common information model? Like, what advantages or efficiencies are you hoping to gain? Because it drives why the model's been developed as well.
So I'm gonna there's more comments coming in about the need to I mean, common language, common training, other things kind of crossing that health services research, epidemiology, data science divide. I want to take a little chair's prerogative and just ask. So many of you closed your conversations with thinking about sort of lessons learned, ways forward, and so on. And I guess, given the work you've done in this area, if you could wave your magic wand and either make a big change because you see something coming in the future, or make a big change because you see an opportunity that you wish people would grab hold of, what would that be? What is it that you see there's a really an opportunity, and now we have these platforms and we may just be able to achieve that if we do things right?
Yeah, it's Geoff here. Look, I think you could answer that question across a whole range of different dimensions of the work that we're doing. So you could start with governance arrangements. I talked about coming up with new, more nuanced models of balancing the issue of the control that a lot of custodians of sensitive data are seeking, with the trust that's required to enable researchers to and analysts to get on and do the type of really valuable work that they would like to be doing. You could think around the whole range of issues that we we've already talked about, data models and so on. And thinking about the architecture around the way that we set up approaches to data. We need, as I think is coming up from a number of the presentations, single agencies, can't achieve these things. We need better partnership arrangements supported by shared funding arrangements, I think would be important. And then thinking about the way that we're using data, there's better data science techniques that we can apply to, get richer insights into the data, but also develop the types of products which would be most useful. So I guess there are a few things that I'd just like to touch on.
Yeah, if I was to add to what Geoff said, I would agree with that. I think in our experience, where there has been success is where there has been an engaged government, and by government I mean both the bureaucracy side and the political side, to enact the necessary legislative changes and then to actually operationalize them, because it's one thing to change legislation, it's another to operationalize them with regulation and then implement, and combined with effective public sector partnerships. So exactly what Geoff was saying, I think that tends to be the recipe for success, and it's pretty difficult sometimes to sustain that over time. What we found, and in fact there was in a previous session, Ted McDonald from New Brunswick was speaking about their experience there, where you often modify legislation or you enact legislation and then realize a year later, oh well, we forgot this, we forgot that, I got to go back again, and that's difficult. Each kick of the can is a challenge, and yet you need to do that. You need to sort of sustain that will and hopefully have political leaders who sort of have drunk the Kool-Aid and realize the value of this potentially for better policy, better service delivery, and better research, and perhaps also driving economic value as well.
So anybody want to add anything else?
I guess just I'll jump in for a second, Kim. There were some things that both Michael and Geoff said there that resonated with me that's happened in Wales. So one of the things Shirley said to us around our collaboration is that she's benefited because it enables BC to operate at pace because of the experience we have in Wales. So lots of collaboration around obtaining data sets, so that view of public data across the sector all in one place in SAIL offers a bigger picture of that individual. So yeah, lots of synergies there around the work that goes on in Wales.
I guess
Emily,
the only,
yeah.
Oh, go ahead,
Go ahead,
Kimberly. Or sorry, go.
No.
I'm looking at your name. I guess the only thing I would add is legislation is only one of our tools. It's really making all of our decision levels at all levels of the organization value data, and that data is a critical asset to support and illuminate our decisions. It's not just to inform them after we've made them. It's changing our mindsets of the role data plays. Once we hit that nirvana, I believe we will be able to move a lot faster than we have, and that we can adjust the scales that I've talked about around the privacy piece. Because right now, because data was viewed as a risk, almost all of our policies started from that point of view. We need to shift the balance. And as soon as we tip that balance, I do think that we can move forward a lot faster without the policy change, or without the legislation changes. Because I think all of the legislation pieces are there. I'll speak for BC, I can't speak for the rest of the other jurisdictions.
Great, thanks. And Emily, please jump in. You're going to get the last word here.
All right, well, hard act to follow, but we have often said that this work is more relational than it is technical. And I think something I would love to see more of, as well as we build these strong governance processes, strong relationships, is to continue to involve the public as well, and to think about the role data can play in everyday lives, and to work on our ability to do that storytelling so that we always are bringing in the larger story beyond the technical aspects.
Great. Thank you to all of our speakers. It's been a great session, and the recording will be available on the conference program within 48 hours. And you may want to watch some on-demand videos and posters that are similar to the ones you saw today. Thank you very much, everybody.